Hi students, so this is week 12 and we're just going to do a little bit of review and then we're going to talk a little bit about how Python is used in cybersecurity, hopefully to get you ready for thinking about your final projects for this class. All right, so on this slide I'm just showing you the big goals for today's lessons. So by the end of this lecture, I want you to be able to explain the main ideas of object-oriented programming, or OOP as we call it. So that means understanding what things like classes, objects, inheritance, polymorphism, encapsulation, and abstraction actually mean without getting lost in the actual technical wording, right? So I also want you to be able to connect those ideas to algorithms, especially by recalling algorithm properties and explaining time and space complexity at a basic level, which we talked about in the past two classes. And then we will connect those concepts to sorting and searching by looking at simple Python code examples, so you can see how the ideas work in practice rather than just as definitions. And then another goal here is to help you see the cybersecurity connection, right? So Python is not just a programming language that we're learning in isolation, but it's a tool that supports many real cybersecurity tasks. So that's from anywhere from automation to analysis to security workflows. So the boxes on the right just summarize how we'll approach the lesson. So first we will explain the concepts in plain English, then we'll compare key ideas so you can tell them apart, and after that we'll look at code examples, and finally we'll be able to apply what we learned in a cybersecurity context. And along the way we'll have some knowledge checks so you can stop and just kind of test your understanding before we move on. So this slide introduces object-oriented programming, or OOP, and the main idea is that instead of organizing your program only as a list of steps or functions, we organize it around objects. And an object is like a digital version of the real-world thing. Each object has two main parts. So first it has attributes. And these are the pieces of data that it stores, right? The second, it has methods, and these are the actions that it can perform. So in simple terms, attributes describe what the object has, and methods describe what the object can do. So the example on the right shows a security alert object, and its attributes might include things like the source IP address, the severity level, and the message, right? The methods might include actions like displaying the alert or escalating it. So we're grouping related data and related actions together in one place. And what this does is it just makes programs easier to organize, especially as they get bigger. And it just helps us to reuse the code. Also to extend programs later, and then it helps us to model real cybersecurity concepts more clearly. So in Python, this is useful because many things we work with in cybersecurity, like users, alerts, packets, files, or devices, can all be represented as objects. So the big takeaway is this. Object-oriented programming helps us think of code in terms of real things, what data they hold, and what actions they can perform. So here we're comparing two common ways to organize a program. So we have the POP and the OOP. POP stands for Procedural Oriented Programming, and OOP stands for Object Oriented Programming. On the left, POP is described as a top-down approach. What that means is you start with the big problem and you break it into smaller steps or functions. The focus is mostly on the actions that the program needs to perform. And this works very well for straightforward tasks or smaller programs. and simple scripts where the goal is mainly to complete a sequence of steps. On the right, we have the OOP, and that's more of a bottom-up approach. This means that you start by building small, reusable objects, and then you combine them to create a larger system. And the focus here is more on what the objects are and what they can do. And this is what makes object-oriented programming especially useful for bigger programs that need to be reused, expanded, or maintained over time. So in simple terms, POP is more step-by-step, OOP is more about building with reusable pieces. And neither one is automatically better in every situation. It just depends on what kind of problem you're solving. So for a quick script, POP is enough. But for a larger system, OOP often makes the code easier to organize and to grow. So here we have a slide representing the difference between a class and an object. So a class is like a blueprint or a template. It tells us what kind of data and behavior something will have. An object is one like actual instance created from that class. So in this example, security alert is the class. And that means it defines what all security alert objects should look like. Then on the right, alert 1 is an object made from that class. And in this case, its severity is set to high. So the class is the general design, and the object is one real version created from that design. And hopefully that makes sense. One important idea here is that a single class can be used to create many different objects. They all follow the same structure, but each one can hold different data. So for example, you could have one alert object with severity high, and then another with severity low, and then another one with a different source IP or different message. This slide also talks about constructors, which is written as _init, . And this is a special method that runs automatically when a new job or object is created. Its job is to set the starting values for that object. Methods, more generally, define what the object can do. So the big takeaway is this: a class is the template, an object is a real instance built from that template, and the constructor helps give that object its starting point. So here we have a simple Python example of a class, so you can see how the class and object idea looks in actual code. So at the top, we define a class called Security Alert. This class is the template for creating security alert objects. Then inside that class, we have a constructor called the _init_. This special method runs automatically whenever we create a new object from the class. The constructor takes in values for source IP and severity, and then stores them inside the object using self.source_IP and also self.severity. So that means that those two pieces of data become attributes of each security alert that we create. Next, we defined a method called display. And a method, again, as we know, is just an action that the object can perform. So in this case, the method prints the source IP address and the severity level. At the bottom, we create an object named alert, and we give it the values 10.0.0.5 and high. Then we call alert1.display, which tells that object to run its display method and print its information. So the main point of this slide is that the class defines the pattern, the constructor gives each object its starting data, and the object is the actual thing we create and use in the program. So in plain English, what is an object? And the answer is A. It's a specific instant created from a class. So it's The class is the template or the blueprint, and then the object is just one real example created from that template with its own actual data values. So here we have 4 big ideas in object-oriented programming. These are inheritance, polymorphism, encapsulation, and abstraction. Together, they help explain why OOP is such a useful way to organize code. So first, inheritance means a child class can reuse and build on a parent class. So simply put, instead of starting from scratch, a new class can take what already exists in another class and just extend it. So that's inheritance. Polymorphism means that the same method name can work differently depending on which object is using it. So 2 different objects might have both have a method with the same name, but each one can behave in its own way. The next term we have is encapsulation, which means keeping data and the methods that work with that data together in one place, while also controlling direct access. So in other words, it helps protect the internal data of an object and keeps the code more organized. Finally, we have abstraction, which means hiding the complicated internal details and only showing the important features. This makes a program easier to use because you do not always need to know or understand everything that's happening behind the scenes, hence abstraction, right? So the big takeaway is that these 4 ideas help make code more reusable, flexible, organized, and easier to manage. And that's a big reason why OOP is so powerful, especially in larger programs. So this slide will show how inheritance and polymorphism work together in an object-oriented programming. So first, inheritance means that a child class can be built from a parent class. And in this example, alert is the parent class, and malware alert and login alert are child classes. So that means that both child classes can reuse the common structure and code from alert instead of starting all over from scratch. So this is helpful because it saves time and keeps the code organized. Then each child class can add its own special features. So inheritance supports reuse, but it also supports extension. Polymorphism is the idea that the same method name can behave differently depending on the object. So in the example here, both malware alert and login alert could have a method called display. Even though the method name is the same, each class can show a different kind of message or output. So together, inheritance and polymorphism make code more reusable and more flexible. So we can create a shared base class for common behavior and then let different child classes customize how they respond or display information. So this slide will explains encapsulation and abstraction, which are 2 of the big ideas in OOP. So again, encapsulation means keeping data and the methods that work with that data together inside one class. So it means we package related information and behavior together. It also helps control access, so code outside the class cannot just change everything however it wants to. And that helps protect the data and keeps the program more organized. The labels at the bottom, public, protected, and private, refer to different levels of access. So public means something can be accessed from anywhere. Protected usually means it should be only used within the class or related subclasses. And then private means it is meant to stay inside the class itself. The main idea is that not everything should be always directly exposed. Abstraction is a little different. Abstraction means hiding the complicated internal details and only showing the essential parts that someone needs to use. So a simple way to think about this is abstraction hides the how and shows the what. In other words, users of the code can focus on what the object does without needing to understand every internal step. So together, encapsulation and abstraction make code clearer, safer, and easier to reuse. And encapsulation helps protect and organize the inside of the class, while abstraction makes the outside of the class easier to work with. So here's a coding example that combines inheritance and encapsulation in Python. So at the top, we define a class called alert, and this is the parent class. Its conductor takes in a message and stores it as a self.message. That means every alert object created from this class will have a message. Next, we define a child class called login alert. And you can tell it inherits from alert because alert is written in parentheses. So that means login alert can reuse the code and structure from the parent class instead of starting all over. And then inside the login alert constructor, we use super, the function super, to call the parent class constructor. And this is how the child class reuses the setup from alert and still gets the message attribute. Then the child class adds its own extra data, which is _user. The double underscore and user is showing private style data. So in simple terms, that means that this value is intended to stay more protected inside the object rather than being directly changed from the outside. And that is the encapsulation part, just keeping the data inside the class and controlling how it is accessed. Finally, the show method gives us a simple public way to display the object's information. So the big takeaway here is that inheritance lets login alert reuse code from alert, while encapsulation helps protect the object's internal data and organize how the data is used. So, which OOP idea is most about hiding internal details and showing only essential features? If you said C, abstraction, you are correct, right? So it's just kind of hiding everything internally. And again, encapsulation will focus more on bundling the data and the behaviors together and then controlling access. So again, we've talked about this a lot. What is an algorithm? It takes input, performs processing, produces output. A problem that can be solved by more than one algorithm written differently. We know that. And then these are the good algorithmic qualities, right? Finiteness, it must stop. Definiteness, it must be clear. And effectiveness must have basic workable steps. We've gone over this many times. And then we also talked, this is review as well. We have the time complexity, which is how the runtime grows. Space complexity, which is how the memory grows. So these are the two factors that we have to consider. And then we have the big O, which is commonly used to describe the worst case growth. The big alpha and the big omega. Big alpha refers to lower bound thinking. And then the, big omega, I said alpha. Big omega is the lower bound thinking, and then the big theta is the last one, which refers to the tight bound. All right, so then we've gone through this, and it's basically just, how much memory is this algorithm gonna take to run, and how much time is it going to take to run. And those are considerations that need to be looked at, right, when we're comparing algorithms. So this slide will give you an example here where we have one loop, and then we also have the nested loop, right? So the nested loop is going to take more time, right? Because it's we have O to the n squared, where here we only have O to the n because it's one pass. And then this table just kind of shows you how that's broken down. As the list gets bigger, the number of operations increases very quickly. And yeah, this table just kind of shows it. The main takeaway basically is the structure of the code matters, right? So a single loop usually scales better than nested loops, right? And then algorithms that can cut the problem down quickly, like having search, can even scale better. And we talked about the search stuff. So which notation is most commonly used in class to talk about worst case growth? And if you said C, you're absolutely right. That's the big O. All right. Some more review. We talked about sorting and searching, right? So sorting is rearranging items in useful order. Examples would be like timestamps, IP addresses, severity scores, common classroom examples that we talked about, selection, insertion, bubble sort. And here we have sorted data, which having sorted data makes analysis a lot easier. And then for searching, it's just like finding specific items inside of collections. We'd be looking for usernames, hashes in CYBR, obviously, blocked IPs. A linear search, this is all review, does checks one by one. Binary search is faster, but you have to have sorted data for that. And then here's just another example for you, which will be useful to look at. And this is linear search. And it's the simplest way to find something in a list. And here we just have some usernames. And we have a target value, which is guess 7. So the program starts with the list and checks each item one at a time from left to right. So the loop is going to go through each position in the list. And then inside the loop, if the if statement checks whether the current username matches the target. If it does, the program prints the index where it was found, and then breaks the loop. And then breaks will stop the loop so it doesn't keep searching after it's already found the answer. So it's finite. And one reason this linear search is useful is that it works even when the list is not sorted. So we don't need to organize the data first. And that makes it a good, simple choice for quick sense. Downside again is that it can be slower if you're working with really large lists, right? Because it's got to go through everything. But yeah. And then the binary search, yeah, so this you have to have sorted data, and it compares the target to the middle of the item and then eliminates half of the remaining search. And we went over this last class, but this is how that works. So instead of checking every item, it just goes in the middle, and then it will look to the left or the right to see, and it will throw away whatever data it doesn't need. It's fast because it keeps cutting the problem in half, but it only works correctly if the list is already sorted. So that's the key there. What must be true before binary search works correctly? I just said that. The list must be sorted. Yes. Okay. All right, let's talk about why Python is so popular in cybersecurity. One big reason is that it's relatively easy to learn. Python makes it great for fast prototyping and automation. You can build useful scripts quickly without a lot of extra complexity. Another reason that Python is cross-platform, so that means that the same language works on Windows, Linux, and Mac, and this is important because cybersecurity, because professionals often work across different operating systems and environments. Also, it's open source, which means it's free to use, and it has a very large community to support it. And it has a huge library ecosystem. There's many built-in tools and external libraries that make it easier to do networking, web requests, cryptography, data analysis, and automation. A lot of examples at the bottom here are some libraries like Scapy, Impacket, Paramico, Requests, and these tools make it especially useful for scripting, security, automation, building cyber tools. So yeah, Python is popular in cyber because it is readable, flexible, it works on many systems, and has a very large set of libraries to help people do things pretty quickly. And yeah, some common uses of Python in threat intelligence, malware analysis, forensics, um, DFIR, that stands for Digital Forensics and Incident Response, vulnerability scanning, security automation, network port scanning, detection engineering, encryption, and decryption. Here's a simple security automation script. And just to get you start thinking about what you wanted to do for your program, for your final projects. And this is a very simple security automation script in Python. The main idea really is that even a short program can automate a useful security check. And here it's asking the user for a password. It's going to check the password using some rules, right? And it looks at the length and checks that, and it looks to see whether the password is all lowercase, as you can see, is lower, is alpha, would be like alphabetic word, letters, and yeah, so even though this is a small Python script, it does automate a very practical security check, and that's one reason why Python is so useful. So which reason best explains why Python is heavily used in cyber? What do you think the answer is? Yes, it's C. It's readable, cross-platform, and strong for automation. All right. So this slide shows several case studies where Python is used in cyber. And this slide will probably hopefully help get you start thinking about your final project and what kind of script you would like to write for this as well. So I'm just going to kind of leave this slide for you to look over. And yeah, so there's a lot of things that we use for in cybersecurity. And yeah, just to wrap up, this was a lot of review, but just wanted to help you get thinking about your final project and what you're going to be writing with cyber related. Again, if you wanted to do something else, just run it by me, so make sure it's okay. If you have like another class that you wanted to do something Pythonic in, let me know. But yeah. So coming up, just continue reading chapter 3 in the text. You will have an in-class activity for this week, which will be out of class because this is online this week. And then no individual assignment, just a quiz and an in-class activity, or an activity, a lab for this. And start thinking about your final projects. And I also have a date for our pizza party, which will be our last class. And I'll give you more information on that and put it up on Brightspace. So that's it. And again, I'll see you next week. Sorry about this week, but something came up that I had to take care of. But hopefully everything will be fine by next week, and I will see you in class. But email me if you have any questions. All right. Awesome.